Time travel is often seen as a fantasy, but there are real scientific principles that suggest it could be possible at least in one direction. To understand how, we need to look at time itself. Time isn't constant as we tend to think. According to Einstein's theory of relativity, time is part of a larger fabric called spacetime. This fabric can bend and stretch based on the speed of an object or the force of gravity. One of the key effects of relativity is time dilation, which means time can move at different speeds depending on how fast you're moving. For example, if you were to travel near the speed of light, time for you would pass much slower than for someone on Earth. So, in theory, if you journeyed to the future by traveling at incredibly high speeds, you could return to Earth and find that much more time has passed for everyone else. This is time travel to the future, and it's backed by real physics. We've even tested time dilation with atomic clocks. When placed on a fast-moving airplane, the clock on board ticks slower than one on the ground. But what about traveling to the past? That's where things get more complicated. While Einstein's equations don't rule it out entirely, traveling backward in time is far more difficult. One idea that might allow time travel to the past is the concept of wormholes. Hypothetical tunnels that could connect to distant points in space-time. If these wormholes exist and could be stabilized, they might allow for travel between different times. However, this idea is purely theoretical and comes with many challenges, including the requirement for immense amounts of energy to keep a wormhole open. Another idea involves rotating massive objects like the Typeler cylinder. If an object with enormous mass were to spin fast enough, it could twist spacetime around it, possibly allowing for a loop that could return someone to an earlier time. However, the energy required to make this work is beyond anything we could currently produce, and the concept remains purely speculative. Even if traveling to the past were possible, it introduces paradoxes that challenge our understanding of cause and effect. For example, the grandfather paradox asks, what happens if you travel back in time and prevent your grandparents from meeting? If they never meet, you'd never be born, meaning you couldn't have traveled back to change the past in the first place. This creates a logical loop that seems impossible to resolve. One possible solution to these paradoxes is the idea of parallel universes or multiverses. In this model, changing events in the past might create a new branch of reality, allowing multiple timelines to coexist. This idea is one way to resolve the paradoxes, but it's still purely theoretical. Despite all the challenges and paradoxes,